That's a little cleaner. All righty. So we're going to talk about more differentiation today. And like I talked about on Monday, we do this big, ugly, scary limit process, and that would be a pure definition of a derivative or the slope of the tangent line. It's the same thing. However, our goal over the next month, month and a half, 2 months is to learn some tricks to make your life a lot easier. Some of those tricks are nice and easy. Like today's lesson, I think you'll find fairly straightforward, and I think you'll be much happier than you were on Monday. But some of them get a little trickier. Okay, but today, easy stuff. Okay, so basic differentiation rules. In fact, we're doing something called the power rule, which allows me and will allow you to not go through that big limit process we just did on problem number 20, but actually in about 3 seconds take the derivative of that function that we had up on the top. Okay, and we're also going to talk about rate of change, which we'll get to that later. Okay. A lot of you should be able to's today. We're going to take the derivative of a constant. What happens when you take the derivative of a function like y equals 2? We're going to talk about the power rule, like I mentioned. Nice, easy way to take the derivative of a polynomial. Constant multiple rule has a fancy name. You're going to do it so many times you're not going to even remember what it's called anymore. And it's so common sense that if somebody in a month says to you, hey, let's talk about the constant multiple rule, you're not even going to know what we're talking about. Okay? Because it'll become second nature. Talk about sum and difference. That's pretty easy. Again, that's also something that you're going to do so much you won't even think about. It wouldn't be the same if we didn't throw some trig in there, because I know you all love trig. And then we're going to talk about something called rate of change, okay? Which is the second thing that a derivative represents. Actually, derivative will represent 3 things. We're starting one with the slope of a tangent line. Today we'll get the second thing, which is a rate of change. Then we'll talk about the third thing, which is velocity. Get a little physics going today. That'll be fun. And I don't know if we're going to get to all this. We're just going to go for a while, and either when I get exhausted or we run out of time or you get exhausted, we'll stop, because that's just how we roll. Okay, so constant rule. Let's talk about some function. Okay, so we've got a function. Remember, we're switching from y equals to the form f of x equals. And so we have a function, f of x equals c, and you can put any number you want in there for c, but we get a horizontal line. Okay? And it doesn't matter what c is, as long as it's a number. What would be the derivative of a horizontal line?
0.
Outstanding. Why?
I kind of already know the rules a little bit, so I just kind of...
Oh, so you're cheating.
Yeah.
Well, what's the slope? If I was to say to an Algebra 1 class, what's the slope of a horizontal line, what would they tell me?
0.
0. Okay. So we're putting those 2 pieces together. Horizontal lines are of the form y equals some number. That's something that an algebra kid never learns. And for us in calculus, we know then that any horizontal line is going to have a slope of 0. So if you take the derivative of a number, you will get 0. That's why it happens, though, because it's a horizontal line. I changed up the notation on you a little bit just to get you more comfortable using both of them. What is the derivative of c with respect to x? Well, there's no x there, so it would just have a derivative equal to 0. Or another way to think of it is, what's the slope of a horizontal line? The slope of a horizontal line would be 0. Okay. So this is what we call beating a dead horse. I'm going to do this over and over again, just so you understand what's going on here. So throw 7 in there, the derivative is 0. Throw 0 in there, you get 0. Now notice I changed the notation on you. So the first one we started with y, then took the derivative, dy dx. Second one we started with f of x, took the derivative to be f prime of x. Third one, change the function, s of t being -3. That's still a number, so s prime of t would be 0. Hopefully you're seeing a pattern here, yes? Again, beating a dead horse. Whoa, what about pi squared? This gets people every time. Remember that pi is a constant. as is E. Do you remember the E number from pre-calculus? Yes? Okay. Well, we do a lot of work with E in this class. Not now, later. Okay, I have sufficiently drilled this into your brain. The derivative of a constant is 0. Now the power rule. Okay, give me a second here. I want to open a window. I'm getting so excited. It's getting warm in here. This is phenomenal stuff we're doing here. Okay, so before I give you the power rule, let's review. In problem number 20 we just did, we took the derivative of f of x being x cubed plus x squared, and we ended up with f prime being 3x squared plus 2x. And I know that some of you probably already know the power rule. If you know the power rule already, give me a what kind of emoji? By the way, I discovered there's new emojis. Did you all know that? Like I didn't know about this one. I didn't know about this one, and I didn't know about this one. Those are all new. The last time I noticed, you could only do the thumbs up and the clappy thing. Okay, so what's the rule? I didn't notice who gave me the thumbs uppy thing. Anybody?
You take the exponent and then you multiply that. What's the word I'm looking for?
I don't know.
Integral with that, and then you lower the exponent by 1.
Couldn't have said it better myself. For those of you that have never seen that before, Prasant just did an excellent job of summarizing. Take the exponent, move it out in front, reduce the exponent by 1. The 3 comes out in front, becomes 3 times, reduce the exponent by 1. In fancy schmancy calculus talk, it's that guy. So taking the derivative of x to the nth, you move the n out in front, reduce the n by 1. Okay, so I filled that entire page in problem number 20, solving that problem, when in fact all I had to do is take this number, move it out in front, and reduce that by 1 to get this. Take this number, move it out in front, reduce that by 1. Done. Okay. Just to make sure we're all on the same page, Marcus, what's the derivative of x to the 7th?
6x to the 6.
Try that again.
Hold on. Wait. I thought it. Wait, why not? I'm confused.
Review what I did down
So
here.
you take the number, put it out in front, and then reduce the exponent by 1.
100%. You said it wrong, though. Say it again.
6x to the 6.
No.
Or 7x to the
There
6.
you go. All right, there we go. Bring the number out in front and reduce it by 1. Well done. Now, what if we got a bunch of things added together? Well, then you just do each individual one. And so some of these things become pretty straightforward. What if there's a number out in front? So what if I'm taking the derivative of 2x to the 3rd? How do I handle that number out in front?
Do you multiply it?
Ooh. Do tell, Cindy.
Would it be like 6x squared?
Well, there's a pretty good chance you're right because I wrote it down. But does everybody agree? So this constant, this 2 out in front, doesn't matter to anything. Okay? It just sits out there doing its own thing. So you could think of this as 2 times h of x. which is kind of cheating. That's not really good notation, but take the derivative of the x cubed, and then when you're done, multiply it by 2. So you are 100% correct. You just multiply the number in front by that number that you bring down. And so you see now how easy this is going to make your life. Yeah? In case you didn't see that, this is really important. You're going to do this ad nauseum for the rest of the year. Do you know what that means? Yeah? Good. Does anybody not know what ad nauseum means? It's Latin. It means until you throw up. Okay, so x cubed, we've done this. Yeah, okay, boom, done. Ooh, ooh. What do I do here? Any ideas?
Is it a third x? I don't know what the power would be.
Ooh.
Actually, no, I take it back.
Not a bad start. I would start by doing this, which you hinted at. I'm sure you all knew that. Taking the cubic root is the same thing as raising it to the 1/3. Okay? Now, don't overthink this. Follow the rule. And what's the rule say? What would g prime of x be? Okay, forget about this problem. What's the rule, Paige?
Take the exponent and move it to the front.
Got it.
And subtract 1.
Good. So what's 1/3 minus 1, Paige?
Negative 2/3.
Outstanding. Good. Now you're saying to yourself, self, what is he going to make us do with that negative exponent? Right now, nothing. But eventually, we're going to have to get rid of those negative exponents by moving it to a denominator. But for now, I just want to make sure that you understand the calculus. Okay? So again, KISS method. Keep it simple, stupid. Don't overthink the problem. Let's see what other goodies I've got cooked up for you here. Yeah. So again, if you're feeling saucy, later on you're going to have to get to that last step. But for now, if you just want to stop with the 1/3 x to the negative 2/3, I'm okay with that. Oh boy. Oh boy. Now what do I do?
Would be negative 2x to the negative 1.
Okay, so you're saying you're going right to the derivative. H prime of x is negative 2x to the negative 1. Cindy, could you explain how you got that?
Well, x squared is in the denominator, so I assumed it was x to the negative 2.
Well, you didn't assume. I mean, that's true. That's not an assumption. But yeah, you're right. Good.
And so then you take the exponent and put it out in front.
Uh-huh.
Oh, if you subtract it by 1, then it would be...
Yeah. Very, very common mistake because negative 2 minus 1 is negative 3.
Right, okay.
Okay? All right. Good. So you might want to take the time to rewrite the function before you take the derivative, especially if this is your first time doing this. For those of you that are seasoned veterans in this kind of stuff, you probably don't need to do that. Again, we don't need that last step right now. Eventually we'll get to that point. If you want to show off, you can get rid of your negative exponents, but it's not a priority right now. Right now, the priority is being able to apply the power rule. This we covered already. I think it was Cindy that showed us, what do we do when there's a number out in front? So there's the notation. There's the fancy schmancy blue rectangle. If you have a number out in front, you just multiply your derivative by that number when you're done. I think we actually did that. We did something similar to that. 2 times 3 is 6. Reduce it by 1, you get x. Oh, a quadratic became a linear term. I don't even know why that one's there. That makes no sense. There's no constant in front of it. Sorry, I don't know what to do. This we did already also. What if you... am I going too fast, by the way? No, we're good? Okay. What if you have two things added together? It's real simple. Just take the derivative of each individual part. So we did that all the way back. Here. Okay, I've got a sum of two polynomials. Take the derivative of one, add it to the derivative of the other one. If it's subtraction, then take the derivative of one and subtract the other function. Yeah, there's some fancy schmancy stuff, but the red is probably what you want. The derivative of the sum is the sum of the derivatives. We've heard that 1,000 times with limits now. Composite function, no, not composite functions, but limits. The sum of a limit is the limit of the sums. Derivative of a difference is the difference of the derivatives. So break it into individual parts. All right, try that one. You solve that, I'll be back in a second. Ooh. Good stuff. Ruby red grapefruit. Delish. Aaron, what do you got for me?
3x squared minus 1.
Say that again.
3x squared minus 1
Close.
minus 4.
There you go. Do you understand why it's 4? Because you got a constant. So yes, the derivative of x is 1, but you have that 4 that you need to multiply together. Good job. Ooh. Ooh. All right, do that one. In case you're wondering, this is the same thing as this.
Mr. Reedy,
Yo.
could you explain why it's 3x squared minus 4? I don't get the minus 4 part.
Good. Okay, so what's the derivative of x? So let's say this is f of x. What's f prime of x?
1?
Good. Do you understand why?
Because if you take it's x to the 1, so if you take the 1 out in front, that leaves you with 0, and x to the 0 is
Perfect. Bring the 1 down, x to the 0 becomes 1. Okay, so what we're doing there is we're taking a line, that's the line of y equals x, and we're taking a derivative, which means we want the slope of the tangent line, and the slope of the tangent line for the function y equals x is 1. Okay, so let's suppose we have a q of x is the line 4x minus 7. The derivative is the slope of the tangent line, and therefore just 4.
Oh.
Got it? Okay, so linear terms like this is, the x just disappears. And you explain perfectly why the x disappears, but from a practical standpoint, just get rid of the x and we're good to go. Aaron, can we come back to you? Go ahead, I'm sorry.
What happened to the 5?
I was just going to ask Aaron that exact question. Aaron, what happened to the 5?
It's 0 because it's a horizontal line, right? And the slope is 0.
Perfect. Did you hear her, Cindy?
Yeah.
Yeah. That's a constant. So the derivative of a constant is the slope of a horizontal line, which we talked to at the very beginning, which would be 0.
Okay, thank you.
Anytime. Kev, what's g prime of x? Want to take a shot at it?
Yeah, I got negative 3 over 2 x cubed plus 9x squared minus 2.
Ooh, almost perfect. Your first term was wrong. You want to look at that again?
Oh, it would be negative 2x cubed.
Perfect. There you go. Because you got to bring the 4 down. Okay. Remember, you
Yeah.
bring the number down before you reduce the power. Well done. Okay. Let's stop. Bella, did you have a question? Oh, you're okay. Just waving your hands in the air like you just don't care. Beautiful. Let's stop there for today because we have some other things, but I think that's I don't know. It's 27. All right, what do you guys think? Should we stop or go? Don't care?
What do you mean by stop?
Well, I have more to do. So there's a big stop here. I originally intended to stop here, but we can finish the lesson that I was going to do tomorrow, and then tomorrow we wouldn't have a lesson. But there is a bunch of people missing. So